Hello and good afternoon to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will discuss a very important concept that is called as context switching. Now, context switching is a mechanism that allows for transition from one process to another process during the course of execution of processes using an operating system. Again, I'll repeat it. So, context switching is a mechanism that allows for transition from one process to another process during the course of execution of multiple processes by the operating system. So, in a multi-programming environment, where there are multiple processes competing for the allotment of CPU time, we need to make transition from one process to the other process so that the execution is judiciously done. So that mechanism is referred to as context switching. So context switching allows for switching from one process to another process during the course of execution of processes using an operating system. So context switching is an essential part of multitasking wherein multiple processes utilize the same CPU at different time slices. So at different point in time, different processes will utilize the CPU in order to perform its desired operations with the help of context switching. Now, on switching context from one process to another, so whenever you are switching context or whenever you are creating a transition from one process to another process, that is the execution, the state of the current running process is to be stored in its own process control block. So definitely context switching is very computationally intensive. So this one we need to understand. So whenever context switching takes place, whenever there is a transition from one process to another process, what we need to do is we need to ensure that the process that is the process from where the transition is started, its state has to be stored in the process control block, because later on the execution has to resume. So in order to resume the execution of the process that is currently suspended or currently being interrupted, so what you need to do is you need to store the state information in the process control block. So it's very much important. So on context switching from one process to another process, that is execution of one process to another process, the state information of the current process is to be stored onto its process control block. So context switching, definitely it's very computationally intensive, because every time context switching takes place between processes, you need to store the state information. So as minimal the context switching, greater will be the computational efficiency. So that is also to be understood. So context switching is a mechanism to store and restore the state or the context of the CPU in process control block for ensuring execution completion. So as the name says, so context switching is a mechanism to store and restore the context of the various processes in the process control block for ensuring completion of the execution. So on completion of the process execution, the state information of the process to be run next is loaded from its PCB and used to set the parameters. So this is also very much important. So once a process terminates, then the other process that is to be executed, its status has to be loaded and it has to be prepared for execution. So now this is what context switching is all about. So context switching is a transition from one process to another process during the course of execution of processes by the operating system. Now this has to be efficiently done, because more the number of context switching, more will be the amount of computation, because you need to restore and store and restore the parameters, the various parameters during the course of execution. So context switching has to be efficiently done in order to not let it hamper the overall system performance. So now let us try to understand what are the parameters that are saved. So parameters that are saved during context switching onto the process control block are the program counter, the instruction that is to be executed next in that particular process, scheduling information, base and limit registers, currently used registers, state information, IO state information, and accounting information. So this we have already learned in the previous class, and we have learned in detail about these parameters that are there that describe the process control block of a given process. So whenever context switching takes place, these are the essential parameters that are to be retained or stored onto the process control block of a given process. So this is what context switching is all about, and this the importance of the same. Now let us try to understand what is inter-process communication. Now, inter-process communication is a mechanism that allows for communication to be established between one process and another process or the other set of processes. So inter-process communication allows for communication of one process with another process or set of processes. So processes may be either independent of each other, or it may be cooperating process. Right, so processes may be independent of each other or may be cooperating process. So, for an example, an antivirus scan and execution of C program. So these are performed by two different processes, but these are completely independent processes. Right? Okay. So antivirus scanner programs will be continuously scanning the computer system, whereas a C program application program will allow you to write and execute C program. So these are completely independent processes, but some of the processes may be dependent processes. For an example, you're performing sorting of files, right? So you need a process for reading the file list or creating a file list. You need a process for sorting. You need a process for displaying the sorted content. So all of these are related processes. So processes may be either independent process or cooperating process. Now, independent processes are not affected by other processes, whereas cooperating processes may be dependent dependent on other processes, or it may be dependent on data, or it may be dependent on invocation. So it may be data dependent or invocation dependent. So independent processes are not affected by other processes, whereas cooperating processes may be affected by others in terms of data dependency or invocation dependency. Now, processes may interact with each other using these two mechanisms. The first one is called as shared memory, and the second one is called as message passing. Now let us try to understand what is shared memory. So shared memory is the memory that can be continuously accessed by multiple processes. So the processes continuously update the shared memory, and the processes whosoever wants to use the information will use the information from the shared memory. So shared memory is the memory that is continuously used by multiple processes in order to perform desired operations. So it is done so that the process can communicate with each other. So it's been shared memories are created now to ensure that processes are capable of interacting with each other. So all POSIX systems as well as Windows operating system uses shared memory. Now likewise you have message queue. So multiple processes can read and write data onto the message queue without being connected to each other. So this is very much important, right? So multiple processes, what they can do is they can read and write data from the message queue without being connected or related to each other. So messages are stored in the queue until the recipient receives the messages. So this is a very simple schematic diagram that shows the way how message queue is being used. So you have a message queue, there are multiple messages. Process A creates messages and places it in the message queue, whereas process B utilizes the messages based on their very purpose. And now likewise you have shared memory. So you have shared memory that is utilized by two different processes A and B in order to perform its desired behavior. So these are the two ways in which inter-process communication may be potentially established between various processes. Now, in the subsequent class, we will be starting with threads, but for now, just let us have an introductory session on threads. So let us try to understand what a thread is. So all of us, we must have come across this particular term many times whenever we are writing a program. Now, it's said that a thread enhances parallelism, right? Okay, or it's a lightweight process. So let us try to understand what a thread is, right? Now thread as the name says, it is a flow of execution through the program's code. So it's a flow of execution. It's one way of executing the process code, wherein every flow of execution will have its own program counter. It will have its own system registers, and it will have a stack. So every flow of execution or every thread will have its own program counter, system registers, and a stack. So a thread in simple terms is nothing but a flow of execution through a process code or a program's code, wherein each flow or each thread will maintain its own program counter, the system registers, and stack. Now it's to be understood here that a process can have multiple such flows. Okay, so a process can have multiple such flows implies that a process can have multiple threads. So each and every thread is assigned with a specific responsibility. So the threads can execute in parallel and reduce the overall execution time. Okay, so a thread, so as I again repeated, a thread is a flow of execution through the programs or process code, where each flow or where each thread will maintain its own program counter, CPU registers, and status registers, and the stack. Now, what does a thread have common, or set of threads belonging to a process have in common? So they have in common the code, the data, and the open files. So threads, a set of threads will share the code, the data segment, and the open files. So whenever any change is introduced by a thread to any of the sections, so it is reflected or known to all the other threads. So this is very much important. So till now what we have learned is that a thread is a flow of execution through a program code or a process code, where each flow of execution will maintain its own program counter, CPU register, and the stack. And we have also learned that a thread will share the code and the memory and the data and the set of files that are associated with the process. This implies when one thread brings about any change to any of the components, it's reflected to all the other threads. So let us go through threads in greater detail. So a thread is a flow of execution through the process code. So a thread is a flow of execution through the process code. So you can have multiple flows of execution through the process code. So each of these flows will be referred to as a thread. So with its own program counter, system register, and stack. So a thread shares information like code segment, data segment, and open files. When one thread alters a code segment, memory, or data files, it is known to all the other threads, right? Because they share the common code. So threads provide a way for improving applications' overall performance through parallelism, right? So say for an example, associated with the process there might be multiple tasks, right? There can be multiple tasks. So multiple tasks like A, B, C. So associated with the process there are tasks A, B, C, right? Okay, so if threads are not implemented, then A, B, C has to be executed at a different point in time. Now if there exists threads associated with the process, then individual process can be assigned with the responsibilities A, B, and C. So threads will be able to execute or attain the set objectives with a lesser time period. So that is the way how thread basically works. So but it's to be understood, again I am saying, it's to be understood that threads are intra process concept. So it is something that belongs to a process, not within a set of processes, right? So thread provides a way to improve application performance through parallelism. So threads basically represent a software approach to improving performance of an operating system. So here what we need to do is here what the thread basically does is it allows for improvement of the overall performance of the operating system. So they also provide a suitable foundation for parallel execution of applications on shared memory multiprocessors. Right? So this is what thread facilitates. So in this particular slide, we have learned that a thread is a way of execution. So there can be multiple ways of execution associated with the process. So in a process, there can be multiple threads. The set of threads that belongs to a process shares code, shares data, and shares open file. So whenever there is any alteration brought about to any of these shared contexts, so these are reflected to all the other threads that are there in the process. So thread provides a way for improving the overall application's performance by enhancing parallelism. So thread represents a software approach to improving overall performance of the operating system, and it provides a suitable foundation for parallel execution of applications on shared memory. So in today's class, what we have learned about is what is context switching, what are the significance of context switching, what happens during context switching, what are the informations that are retained or stored whenever context switching takes place, and why context switching is computationally intensive. Then we moved on to interprocess communication, where we learned about what is interprocess communication, what may be the different types of organizations that may be possibly there between processes, where you learned that processes may be independent of each other, or processes may be data or invocation dependent. Then we've learned mechanism for ensuring interprocess communication, where we have learned about shared memory and message queue, message passing or through message queue. Then we have learned in detail about what is shared memory and what is message queue, and then we have represented the same with the help of a very simple schematic representation. Then we moved on to threads, so where we learned that what is a thread actually, what does threads within a particular process share, what does thread facilitates, and then eventually we've learned that threads basically provide a very sound suitable foundation for parallel execution of applications on shared memory. So in subsequent class we'll learn about threads in greater detail, and then we'll learn about different types of threads. So thank you very much. Have a very nice day.